So today we move to the machine learning concept and specifically to Azure machine learning. So we will observe how we can realize the machine learning tasks in Microsoft Azure, but previously it is important to talk about the machine learning concepts. As it is not a in-depth course about the machine learning, here I give you some examples of some concepts and examples of the machine learning. So machine learning can be distributed as computer systems that improve with experience. So previously, as you realize some programming stuff, you just have the program and you give it several parameters and it give you the output result. In machine learning concept, it's a little bit different as you need to train your model on a large amount of data, and then your model will be able to predict the results as it is already as it is have been trained on a large amount of data, so it has learned and it has experience. So here, like you can see, I will highlight you the important part. So the software models that are trained from huge volumes of data, then used to predict certain patterns, trends, and outcomes. So this is what you need to know about machine learning concepts. And there is also another feature as predictive analytics. So it is underlying technology. It is used to predict the future to have the best suitable outcomes. So predict the future from the results trained before. So, and here I have a slide that describes the difference of machine learning in comparison to today's modern computer programming paradigms. So here we will talk about the difference between these features. So in the machine learning, so like in the traditional programming models, programs and data are processed by the computer, so to produce the desired output. So you give some data, maybe it is an array, and you want to count the sum of the elements of array. So here you have this small array, then you give it to your program and you receive the output result. So this is what you do mostly all the time in your programming. So the next part, this is like the traditional. You have the data, you have the program, and you have the output. And you have the computation. The computation is done on your computer. So here we move to machine learning, and this paradigm is altered dramatically. So it is different, this paradigm. You have the data as previously, but not the kind of data like an array, but it can be a large amount of data usually to have so it is enough to train your model in a good way. Uh, and then you have the result, like so it can be a labeled data or the just a rough data, but anything it has some result. Maybe this data shows how it is classified, or like the trend when you have the regression, so you see the line. And then you want to create like this small program, this small model that will be able to produce the results on the data that, for example, on the data that is given to the program, but it is mostly the same as the data it was trained, but it is not labeled and it is not completed. So the power of this new program, so it can effectively predict the output. So based on the supplied input data. So now our program is able to give some result. And it is based on what has learned previously. Like here, the program that is developed has been trained. So it has been trained via massive quantities of learning data. So here, this part is very important. So you need to know via massive quantities of learning data. For example, if you give it like dozens of input data, it cannot be enough for it to learn, and your output predictive result is very just incomplete, inaccurate. So it will not produce a satisfiable result. So, and also the predictive analytics. So it is related. Like for example, it's used by large companies, so they want to have the prediction of what they will get in the future. So, and as a example, it can be also used for customers. So, for example, they bought some item and the company would like to provide them with the items they want to buy later that are related to what they have been looking for previously. So the past experience allows them to predict what the customers will mostly have in the future. So what they mostly like in the future, what they want to buy in the future. So it will allow the company to create a highly effective marketing strategy. So this is a key features of machine learning and predictive analytics. And so actually there are many ways you can realize the machine learning. So you can mostly code everything by hand, just write the code in the editor on Python or R, for example, languages, and other languages. For example, some languages have already added the machine learning libraries that you can use, but in many ways it is very useful to program in Python or R language because they provide more opportunities for machine learning tasks. But as our course is not about the just the programming in machine learning and it is a cloud realization, so also uh, Azure provides the so-called machine learning studio that allows you to build some blocks uh, where the code is written. So mostly all algorithms are included in the building blocks, so you can use them to realize the machine learning program. So this is called Azure Machine Learning. As you have already observed, your window in Azure, you have probably seen the part that is related to machine learning, but actually there are two ways, just the classical way, because the Azure is also developing, so there is a machine learning studio that is like a little bit separate, where you can just run the experiments and not to configure on what machine you want to run this experiment as in Azure, but you can realize both approaches. So what is important here? So machine learning, Azure Machine Learning is able to quickly create machine learning experiments, evaluate for accuracy, and then uh, you want to predict the results in your model. So in order to work significantly in Azure Machine Learning, you need to have you need to have some underlying data science principles. You need to know like the names of algorithms and how they probably work, but actually you can read about them and the good way that you don't need to learn completely how to write this whole code of the algorithm, because now they realized you need to mostly use your own data, your prepared data, to connect it to the block with the that realizes this machine learning algorithm. So I think this is a good way to have this machine learning experience with big data, as you don't need to have uh, so many practicing experience. Uh, so what is here we have in machine learning Azure as mostly in other the concept, you have the data. So data is very important. You can have your own data on in Microsoft Azure Studio. There are some sample data that is already provided to you, which you can use. So then you need to create the model. Uh, then you train on it and test the results while like this deploying. So you deploy the model, it starts to work, and you will have the results on the test data. And you can evaluate the model, you can look at the results, what results you have. Is your results. So here you can have your results and to look what how good your task was realized. In ways you can look at the machine learning metrics like accuracy, precision, and to evaluate the obtained results. So this is a look of Azure Machine Learning, like here. So I have already done some experiments that have been provided to you. And we will just run some of them and take a look what we have. Just let's move. So how I run it, just using your Microsoft account, so you can type Studio Azure ML or just type in Google. As there is a classical Azure ML like this Microsoft or Azure Microsoft ML Studio, so here you can have this classic. Maybe it will be more convenient for you to work with it because you don't need to configure so much. It is like it is a part of Azure, but the interface is a little bit different and uh, some configuration. You don't need to do some configuration, but you can also create the resources for machine learning platform in A specifically, and then you can create experiments there. But here you just use your login. You select the region, like where you realize your experiments. Okay, then we connect to it. So here you can have some sample experiments to take a look how it is realized. So let's have the classification like this. Oh, it's quite in this example, quite much data. I think I can show you better my experiment as it is. Like here, just a small experiment for classification. So here is a data set about some results. So here we have this like data with some metrics. Like here what we have. So this data is about forest fires. So this data is about forest fires, and we can take a look what is here. So for example, there is a month, day, and the amount of rain, the wind data, temperature, and we want to find out whether there was a fire, the degree of the fire, yeah, for this specific role. Okay. Uh, so here we select the columns. So like we here use all the 13 columns, but they can be different. So we can have, and then we split the data. So now it will be the train data. It will be the train data, and it will be the test data. So here, uh, so I need to show you what it means. So the train data, uh, it is what you will use to train your model, so it will be able to predict the results. Like here we have 517 rows, and we want to use like 70% of these rows to train your model. So we will randomly take 70% from 517 rows, and other 30% we will use for predicting the result. And as we have the results here, we can compare like this Y result, what we will get by our model and what is the real result. And using this data, we can evaluate how good our model is. So this block realizes this train split data on train and test. And here we choose a like so-called machine learning algorithm. So the decision forest. Uh, so So we can use like an example another machine learning algorithm. Uh, so to explain how this algorithm works, you can uh, read it, read about each of them. Just type the machine learning, like random forest. And you can have the pictures how this works. So generally we will use the tree, the binary tree, where it will put the data in one side or in other side. But in the decision tree, like this decision forest, we will have a large amount of these trees. So, for example, here is the number of trees is 10. Let's change it to 15 uh, to take a look how our result changes. And here, as we talked, we want to split our data 70% for training and 30% for testing. Then we train our model. This area is a train data. So here will be the test data. Then we score model and evaluate the results. Okay, let's save it and run. Now it's showing what blocks are executed. So here we use like this matrix, like the relative absolute error, or root mean squared error, or mean absolute error. So to find out how many has been um, here we use a regression model. That's why the errors like this. So we want to find out the difference between the real result and the predicted results, and we find out what is the error between the prediction and the real result. So here you see it was 155 rows. So this is 30% of our data set. So it will lead, as I told you, on 70% for training and on 30% for testing. So 155, this is a 30% of what we had here. Yes. 517. Okay, let's have the example of the classification. Yes, I should have it already built. So let's go to experiments. So the multi-class classification. Uh, so I want to visualize them. It might be in this example. So here is the data of the images classification. So it will be clearer for you. As you see here, this is 0. So this rows column. So actually there are 785 columns. This is for image classification. As you know, we can, as we have our image, but we have to represent it in numerical values in order to do the operation with it. That's why there are many zeros and there should be okay, we have 222, 225. As you know, we called the color of the pixel as 0 or 255, and so we cut down the whole our image row by rows and columns by pixel, and each pixel is represented by the color, and the color is from 0 to 255. That's why you will see like this. Many zeros. This is for white font. And we have yeah, like this, the numbers, different kind of numbers, but it doesn't show all the rows. And here we have our class, for example, for this 54019. So there are 10 classes. So the first kind of image can be related with roads, cars, and maybe other kinds. So these labels are created by humans. So human labels them to what type this image, what type is this image. So now we use a multi-class logistic regression. So logistic regression to classify them. And then we can evaluate how precise was our model. Okay, let's run it. Oh, it was quick. So now you see that is predict that like here we have 0 and 0, and the accuracy is 97%. So it means that there were 97.8 right predictions where the class was 0 and it was actually 0. And here we can have like this 0.2. So the actual class was 0, but our model predicted that it was class 2. Actually, these are very good results. As you see, it's above 90%. Because this data is very well edited, MNIST, so not MNIST, it's image data. So this is a prepared collection of images. So it's quite a huge amount of them we used for train. So how much was it for train? Let's look once again. So there was 60,000 rows. And for test we used 10,000 rows. Okay, this is a good, the data well prepared and the results are good. So this was about the core concepts of machine learning and its realization in Microsoft Azure Machine Learning Studio. So I hope it was clear for you, but don't pay too much attention on the names of the algorithms. I just wanted you to be familiar with these core models.